All right, today we're going to run a little cosmic simulation, but one with some pretty catastrophic potential. We're asking a wild question that's actually based on real science. What would happen if alien worlds, actual known exoplanets, were suddenly just dropped right into our solar system? So yeah, that's the big question, right? When these cosmic intruders show up, who makes it? Who gets completely destroyed? And maybe most importantly, what does it mean for us back here on Earth? The answer? Well, it really shows you just how fragile our cosmic home is, and how easily that delicate balance could be tipped. So here's the game plan. We're going to take 4 actual known exoplanets, and we're going to drop them into our solar system, one by one. We'll explore what happens to the visiting planet, sure, but also what the consequences are for us, both what happens right away and what happens way, way down the line. Okay, first up is TRAPPIST-1e. Now, you might have heard of this one. It was a huge deal for a while, a top candidate for being Earth-like. So it seems like a pretty subtle guess, but as you're about to see, even a small nudge can have catastrophic consequences for a system as finely tuned as ours. I mean, look at it. At first glance, you'd think TRAPPIST-1e would be a perfect neighbor. It's a rocky world, just a little bit smaller than Earth. You'd think, hey, it could just slide right in here, no problem. But in the world of celestial mechanics, it's all about location, location, location. Its fate totally depends on where we drop it. You put it in your Mercury, it's toast. It gets scorched and any water boils off in just a few years. But if we stick it out in the asteroid belt, it freezes solid. And that's where the real danger for us kicks in. Its gravity, over millions of years, starts acting like this cosmic slingshot, flinging asteroids right into our part of the solar system. See, this is what we mean by a long fuse. The danger here isn't some big, sudden explosion. It's this slow, creeping chaos. For millions of years, everything seems totally fine, but all the while, the risk of a catastrophic extinction-level impact on Earth is just steadily climbing. That small intruder? Yeah, it just created a massive, long-term headache for Earth. All right, let's ramp things up for our second case. Meet Kepler-442b. This one's a true super-Earth. This intruder is way more massive, and believe me, the effects are way more immediate and way more powerful. The huge difference here, it's all about the mass. At 2.3 times the mass of Earth, Kepler-442b has a much stronger gravitational punch. That one little number changes everything, both for the planet itself and for all of its new neighbors. Okay, so if we drop this thing in, say, around where Venus is, it instantly becomes a super Venus. Its oceans boil away into a thick, crushing atmosphere, and a runaway greenhouse effect turns it into a total hellscape. And for us, its mass starts this slow, relentless gravitational tug-of-war with the inner planets, threatening to shift our orbits, trigger collisions, or cause devastating climate change over thousands of years. Okay, our third case brings a totally different kind of threat to the table. This is OGLE-2005-BLG-390Lb. Let's just call it OGLE for short. It's a cold heavyweight, and it acts like a quiet, gravitational shepherd of total destruction. Whoa. At 5.5 times the mass of Earth, OGLE is a serious gravitational player. It's a cold, icy world, but the danger here isn't about its temperature. It's all about its raw weight and where we put it. So we place OGLE in the asteroid belt, and, the planet itself doesn't really change much. It stays frozen and quiet. But its gravity, it starts to just systematically take apart the asteroid belt. It acts like a shepherd, yanking asteroids out of their nice, safe orbits and just chucking them right at the inner solar system, right at us.
So here we go again with another one of these delayed threats. At first, you wouldn't even notice. OGLE's just this quiet, far-off object. But then, millions of years down the line, the sky literally starts to fall. It's a cosmic ambush, a slow-motion disaster that a civilization wouldn't see coming until it was way, way too late.
All right, for our last case, we are going big. I mean really big. Say hello to J1407b, the Super Saturn. It's a planet so massive and so spectacular that its danger is just as epic as its appearance. Just look at these numbers for a second. We're talking 20 times more massive than our own Saturn, and its ring system is hundreds of times wider. If this thing was in our solar system, the view from Earth would be absolutely mind-blowing. But that beauty? It's hiding a serious danger. So let's drop this behemoth between Saturn and Uranus. What happens? An insane chain reaction.
Its enormous gravity starts tugging on the gas giants, messing with their moons, and sending icy objects from the Kuiper Belt flying inward. But here's the real danger. Even a tiny little push on a giant like Jupiter can create a domino effect that cascades all the way down to Earth, changing our orbit and our climate forever.
Okay, so after running through 4 totally catastrophic scenarios, what's the takeaway? What have we actually learned here about the fundamental principles that keep our solar system in this incredibly delicate balance?
You know, it really just boils down to 2 simple things: mass and distance. How far a planet is from the sun decides if it fries or freezes. And its mass, well, that decides just how much gravitational chaos it can stir up. Those 2 simple factors were the main drivers of destruction in every single one of our simulations. So let's do a quick recap. We had TRAPPIST-1e, the slow nudge; Kepler-442b, the super Venus that created a runaway greenhouse; OGLE, the one that weaponized our own asteroid belt; and finally J1407b, which set off those system-wide gravitational dominoes. And what did every single one of these scenarios point to? 2 ticking time bombs that are already here: the asteroid belt and the Kuiper Belt. They're just waiting for a little push to send them hurtling our way.
And all of this brings us to one final and honestly pretty chilling question. What if our telescopes spotted one of these intruders tomorrow? What if we knew catastrophe was on its way? Maybe in 1,000 years, maybe in 1,000,000. What could we even do about it? It really makes you stop and think, doesn't it? About our tiny little place in the cosmos and just how unbelievably fragile this whole setup really is.